In this video, we'll be going through questions 13 through 24 from the June 2023 Geometry Regents. Number 13, on the set of axes below, triangle DEF is the image of triangle ABC after a dilation of scale factor 1/3. We're asked to find the center of dilation. Okay, for this, I would use our answer choices and go through them and see if we can find one that will kind of verify that scale factor of 1/3. So what that really means here is that the distance from the center to each point should now be cut by 1/3. So let's look at choice 1, 0, 0. Okay, the distance from 0, 0 to, let's say we use B, was left 1. I'm not going to actually even calculate the distance. I'm just going to talk about the horizontal and vertical distances here. Was left 1 and up 6. So if I was dividing this by 3 or multiplying by 1/3, I would be going left 1/3 up 2, and that would mean E should be here. And that's not the case here. So I'm going to say choice 1 is incorrect. All right, let's try choice 2, 2, -3. All right, from here to, I'll use C this time. I'm going 1, 2, 3, 4, 5, 6 to the left. 1, 2, 3 up. So if I divide those, each of those values by 3 or multiply by 1/3, I'd be going, I'll do this in a different color, left 2, 1, 2, up 1. And you can see that lands where F is, and that works. That's what we want to happen. That means the dilation is showing 1/3 as the scale factor. And I could do the same thing for D and E, and that will verify my answer, but the answer is yes, choice 2, 2, -3. Number 14, in the diagram below of isosceles triangle AHE, the vertex angle is at H. We know that CB and AE are perpendicular, and that FD and AE are perpendicular. So I'm just going to draw some right angles in there. We want to know what statement is always true. And I see here that we just have 4 different proportions. So that tells me that I need to look for corresponding sides. So corresponding sides are proportional. And this is the case in similar triangles. So here's how I know the triangles are similar. And when I say that, I'm referring to triangle ABC and triangle EDF. They both have a right angle. And I know angles A and E are congruent because we know the triangle's isosceles. So those two triangles are similar by angle-angle similarity theorem. And now we can say, okay, the corresponding sides are proportional. So let's see what answer choice actually has corresponding sides for us. Choice 1, AH to AC. EH to EF. If I take a look at that, so again, AH to AC, EH to EF. Now, that looks good. My only concern with that here is that AH and EF are not part of the actual triangle. So let's take a look at choice 2. AC corresponds to EF, that's true. And AB corresponds to ED, that's true. So this one looks like it's the answer to me because those are actually corresponding sides of the similar triangles, whereas choice 1 was not talking about the similar triangles. 15, rectangle ABCD has 2 vertices at coordinates A, -1, -3, and B, 6, 5. The slope of BC is. Okay, well, notice they're giving us AB, but we want the slope of BC. So if you have a rectangle, and I'm not even going to draw this on graph paper here, but let's just say I have a rectangle and it looks something like this. A, B, C, D. AB and BC are going to be perpendicular to one another. So that means their slopes are negative reciprocals. If you prefer to graph this, absolutely go to your scrap graph paper, graph. You can even find the slope that way through I's over run. But let's find the slope of AB. So y2 minus y1 over x2 minus x1, I get 8 over 7. But we want basically the negative reciprocal of that. So BC's slope will be -7/8, which is choice 1. 16, in right triangle ABC, A is 90. So label A as the right angle. B and C you could put in the other 2 spots. Angle B is 18. AC is 8. And we're looking for the length of BC to the nearest 10th. This is going to be a SOHCAHTOA, or right triangle trig problem. So where the 18 is, here's my opposite side, adjacent hypotenuse. I am going to be using sine here, the opposite and the hypotenuse. The sine of 18 is 8/x. Let's cross multiply that. 8 equals x sine 18. Divide by the sine of 18 to isolate the x value. So 8 divided by the sine of 18 is going to give us 25.888, and to the nearest 10th, that is choice 4, 25.9. Number 17, the measure of one of the base angles of an isosceles triangle is 42. The measure of an exterior angle at the vertex of the triangle is. Okay, so let's draw this out. So let's say we have an isosceles triangle. That means 2 congruent sides. And it also means the 2 base angles are congruent, and we know they're both 42. Okay, well, based upon that, we can find the vertex angle, subtracting from 180, because we know every triangle has 180 degrees. Don't worry about that being inaccurate here in terms of like not looking like it's to scale. And we want to find the measure of the exterior angle. Let me draw that a little bit better here. So here's our exterior angle. These 2 must be supplementary, and therefore that angle is going to be choice 2, 84. You also could use the rule that the exterior angle is equal to the sum of the non-adjacent interior angles, so that 42 plus 42. Number 18. In the diagram below, we can see that AFKB is parallel to CHLM. I'm just going to mark that. FH is congruent to LH. Okay, so anytime we read a fact, let's mark it, especially because we have a lot of facts here. FL is congruent to KL. So I'm going to put 2 tick marks on each of those. And LF bisects angle HFK. So these 2 are congruent up here. When we have an angle bisector, that means that angle is split into 2 congruent parts. All right, now we have to decide which statement is always true. If we look at the answer choices here, they're all talking about angles. We're talking about maybe multiplying some by 2 or some being equal. All right, so remember we want it to always be true. We have to be very confident it's a true statement. Let's go through the answer choices. Choice 1, the measure of angle HLF, okay, so I'll just mark here, is, if I double it, is equal to the measure of angle CHE. I have no reason why that would be true. I don't even have any markings around there. So I'm going to leave that out. Choice 2, doubling angle FLK is equal to angle LKB. It's a really similar answer to choice 1. And again, I just have no reason that I know that that's true. So I'm going to take that out as well. Choice 3, the measure of angle AFD, so here, is equal to the measure of angle BKL. These don't even really look congruent to me, so I have a feeling that these 2 angles are not equal. But let's see what choice 4 brings. So it says the measure of angle DFK is equal to the measure of angle KLF. All right, these 2 at least look congruent. Let's see if we can find some way to basically verify that. Well, if I go off of the congruent angle markings I have before from the angle bisector, I also know that angle HFL and angle HLF are congruent because that's an isosceles triangle. And I know that's also congruent to angle LKF because that's an isosceles triangle. Okay. If I take a look at this here, let's just make up numbers for a second. Okay, I'm going to purely make these up, and let's say that this angle is 50, and this is 50, 50, and 50. Sometimes I think when questions are pretty abstract, making up a number can help us. This means that this angle would have to be 80 degrees, right? Because that triangle must add up to 180. That means this angle must be 80 degrees because these are angles on a straight line, which add up to 180. And now you can see choice 4 is true because those two angles that they're talking about definitely have equal measures. 19, the line whose equation is 6x plus 3y equals 3 is dilated by a scale factor of 2, centered at the point 0, 0, an equation of its image is. So what I'm going to do is I'm going to just write this equation here, and I'm going to get it in y equals form. So I'm going to move the 6x to the other side. I'm going to divide everything by 3. And now I have y equals negative 2x plus 1. The point 0, 0 is not on this line, so it's off the line. Anytime the center of dilation is off the line and is the origin, what you're going to do is you're going to keep the slope the same, and you're going to take the y-intercept and multiply it by the scale factor. Okay, so the slope will never ever change. Parallelism is preserved under a dilation. So that would mean I get y equals negative 2x plus 2, because I'd be multiplying 1 times 2, and that would give us choice 2 is our answer for number 19. 20, which figure will not carry onto itself after a 120-degree rotation about its center? The rule for this when you're doing rotational symmetry is 360 divided by the number of sides. If I do that for choice 1, I would get 360 divided by 3, which would give me 120, so choice 1 is out. Choice 2, I'd get 360 divided by 6, since it's a hexagon, I'd get 60. But remember, any multiple works, so if I multiply that by 2, I get 120. Choice 2 is out. For 3, I would do 360 divided by 8. Since it's an octagon, I'd get 45. And I want to see if I keep doing multiples of this, will I hit 120? 45, then times 2 is 90. 45 times 3 is 135. You can see I skipped over 120 here, so I believe choice 3 is going to be the answer here. Okay, but let's verify. Choice 4 would have been 360 divided by 9. A nonagon has 9 sides. That would give me 40 degrees. And if I continue to find multiples, 80, 120. So choice 4 would also give me 120 degrees. So the answer is definitely 3. 21, triangle ADF is drawn. BC is parallel to DF. Let's mark that. These triangles are definitely similar to one another. That's because they both share angle A. So A is congruent to itself by the reflexive property. And therefore, those triangles are similar. Similar triangles have corresponding congruent angles and corresponding proportional sides. All right, so 21, choice 1 asks us, is AB to BC, okay, so AB to BC equal to BD to DF. That's not going to be true because when I look at this, BD is not the side of a triangle. If you have trouble seeing that, what I would also maybe suggest, and don't worry about it being accurate, but draw the picture separately, and you can really see this nicely here. So if I look at this here, I have AB, so watch in my new picture, AB to BC, and then it says BD, which doesn't even exist here, to DF. So you can see that's not going to be right, so it's not choice 1. Choice 2 says, is BC half of DF? I don't necessarily know that that is going to be the case here. So, I mean, maybe it looks it, but I don't know anything about the scale factor being 2. If I knew B and C were midpoints, that would change things, but I don't know that here, so I'm going to cross off 2. 3 is basically writing choice 1 differently. Instead of writing the proportion or the ratios with a fraction, they're using a colon. So if you're not used to seeing it that way, what you could do is rewrite this. And now it says, is AB to AD equal to AC to CF? Nope, very similar to choice 1. CF is not a side of the triangle, so that's out. So we're really only left with choice 4, but let's talk about why it is 4. Angle ACB, okay, so that's this angle here. Let's erase some of these markings so we can see. So that is, I'll actually highlight it here. Angle ACB is congruent to angle AFD. Yes, that is true. Those are corresponding angles, and therefore they are congruent. 22, in triangle ABC, M is the midpoint of AB. N is the midpoint of AC. Okay, let's draw this out. So I have triangle ABC. So A, B, C. M is the midpoint of AB. N is the midpoint of AC. And we know if MN is x plus 13 and BC is 5x minus 1, what is the length of MN? Well, MN is now a mid-segment, which means it's half the length of BC. So if I double the mid-segment, it will be equal to the length of the parallel side. So 2x plus 26 equals 5x minus 1. Get your variables on the same side. Get your numbers on the same side. And I get that x is 9. Notice 9 is an answer choice. It's just not the right answer choice because we're looking for the length of MN. So plug in, you get 9 plus 13, or 22. '23. In the diagram below of isosceles trapezoid STAR, diagonals AS and TR intersect at O, and ST is parallel to RA, and you have non-parallel sides SR and TA. Okay? So basically it's just describing this trapezoid. One thing I want to note here is since it says the trapezoid is isosceles, I know now that SR and TA are congruent to one another because in an isosceles trapezoid, the non-parallel sides are congruent. And I also know that SA and RT are congruent to one another because in an isosceles trapezoid, these diagonals are congruent to one another. It says, what pair of triangles are not always similar to each other? All right, so this definitely looks like a lot to look at here. Let's try our best to use our answer choices. So choice 1, STO and ARO. Are these similar to one another? Okay, they are, and I'm going to erase some of these markings in here for just a moment. They're similar by angle because I know that these are alternate interior angles. These are alternate interior angles. I could even use these vertical angles. So these are definitely similar to one another. It's not going to be choice 1. Choice 2 is talking about triangle SOR and TOA. And we want to know again, do we know that these are similar triangles and how can we basically justify that? Okay. So for this question here, I know that these angles in here in those triangles, SOR and TOA, I know that those are vertical angles, and vertical angles are always congruent to one another. Okay. All right, now let's talk about the actual measurements of the remaining angles and if we know they're congruent. I do in fact know that this angle and this angle are congruent since this is an isosceles trapezoid. That would make the base angles congruent to one another, and while they're being cut by the diagonals here, those are still going to be congruent. So these triangles are in fact similar by angle. All right, for choice 3, triangle SRA, I'm going to use a highlighter here, and triangle ATS. This one definitely looks incorrect to me. Like, we don't know that these are similar to each other. You can kind of just look at the angles and see that they are not, the corresponding angles are not congruent. But can we basically verify at all that any of the angles from one of these triangles is congruent to the other? No, we can't. So these are going to be our answer here as to why they are not always similar. All right, finally, our last multiple choice question. The endpoints of AB are 0, 4, and negative 4, 6. Which equation of a line represents the perpendicular bisector of AB? All right, well, first let's start with the slope of AB. Okay, you could also choose to do this graphically if you prefer. I'm going to do it this way. So 6 minus 4 is over negative 4 minus 0. So the slope of AB is negative 2. negative 1/2. When we find the slope of the perpendicular bisector, they're going to be negative reciprocals to one another, so that's going to be positive 2. Now we have to find the midpoint of AB. A bisector goes through the midpoint. That's going to be using the midpoint formula. Add the x's, divide by 2, add the y's, divide by 2, and I'm going to get negative 2, 5. Now we're going to use these two pieces together and write the equation of a line. I'm going to use point slope form. Y minus y1 equals m parentheses x minus x1. So y minus 5 equals 2 parentheses x minus negative 2. I'm going to change those to positive. So this is when I distribute, I get 2x plus 4. And when I get y by itself, I get y equals 2x plus 9. And that will give us choice 4. Head to the next video in this playlist to see the answer to the part 2 questions.